Hello everyone, this is Kalpana, working as an assistant professor in SNS College of Technology at Artificial Intelligence and Data Science Department. Today we are going to discuss a case study on stack data structure.
Hello everyone. Today Dakshini from AIDS department is going to present a case study on Tower of Hanoi.
Stack is used in different real world cases. For example, undo redo operation we can use it, like in text editors like MS Word and all. And next, browser navigation, we can back and forward buttons. In call stack, in programming languages also we can use. And parenthesis matching in compilers and all we can use. And expression evaluation like calculators and all we can use. Good morning everyone. Today I'll take a lesson about stack. Stack is a linear data structure that performs operations in a LIFO order, which means last in first out. Suppose we have a stack full of items like 10, 20. We are gonna enter 30. So we are gonna push 30 into the stack. So it will come up only because it is LIFO, last in first out. So if we pop this element out, we will pop 30 only again. Last in first out. The last element we are entering into the stack will be removed as the first element out. So if we consider a stack of plates, the first we enter a plate into the stack. So if somebody takes the plate from it, they will take only the first again. So it is a similar way to it. And there are different operations like pop, which is used to remove an element from the stack, and push is used to enter an element in the stack. This empty operation is used to view if there is an empty stack or no.
About the Tower of Hanoi. The Tower of Hanoi problem consists of three rods A, B, C and a set of disks of different sizes. The objective is to move the entire stack of disks from rod A to rod C. The subject to the rule mentioned earlier. Recursive solutions. Recursive solutions is to Tower of Hanoi problem involve breaking down the problems into smaller subproblems. The basic idea is move n-1 task from rod A to rod B using rod C as a temporary storage. Move the nth disk from rod A to rod C. Move the n-1 disk from rod B to rod C using rod A as a temporary storage. For this, using this algorithm, by using this algorithm, if there is only one disk, move it from the source rod to the destination rod. If there are n disk, move n-1 disk from the source rod to the auxiliary rod using the destination rod as a temporary storage. Move the nth disk from the source rod to the destination's rod. Move the n- disk from the auxiliary rod to the destination rod using the source as the temporary storage. So time complexity of the Tower of Hanoi problem is order of 2 power n, where n is the number of disks. This is because each recursive calls branches into 2 more calls, resulting in an exponential increase of the number of moves. And space complexity. Space complexity of the Tower of Hanoi problem is order of n, where n is the number of disks. This is because the maximum depth of the recursion tree in n. Its applications have algorithm designs. The problems illustrate the use of recursive and divide and conquer strategies in algorithm designs. It's a problem solving helps develop critical thinking and problem solving skills. And cognitive psychology is problem is used to study cognitive process such as problem solving and decision making. The real world.
As told earlier, now we will consider an example for Tower of Hanoi. We have 3 rods A, B and C. We have 3 disks on game. Our condition is to move 1 disk at a time, and we have to place in the same order as in the A to C. That is our finding step. So first we move the smallest disk from A to C, and next we move from the second disk from A to the position B, and next we move from the C to B. And now we move from A to C. Next we move from B to A. Next we move from B to C, and finally we can move from A to C. Now we have the final result has in the same order we got in the initial stage.